OSPF adjacency neighborship. So today we'll discuss about DR-BDR concept. Okay, in multi-access networks such as Ethernet, if DR-BDR, this one is only in Ethernet. When your network type is multi-access, that is Ethernet. In OSPF it is called broadcast. So we have DR-BDR. Okay, and DR relation is per interface. Means this is one segment. So for example, this is our topology. So we are going to have one election here on this segment, one here, one here. So every segment has a separate DR. Okay, so DR-BDR is per interface. Okay, and there is no election on DR-BDR on point-to-point link. Okay, so let us see why we need DR-BDR. In multi-access networks such as Ethernet, there is a possibility of many neighbors relationship on the same physical segment. Like example, here you can see there are 4 routers connected. Okay, and if you one want to form neighborship with every other router, okay, full mesh, that is full mesh. The formula for full mesh is n into n minus 1 by 2. This is the general formula for full mesh, where n is equal to number of nodes. Okay, suppose there are 4 routers on the segment, then the number of neighborship will be 4 into 3 by 2, that is 12 by 2. Total number of neighborship will be 6. If you add one more neighbor now to the segment, then it will be 5 into 4 by 2, that is 10. Okay, as the number of neighbors, number of routers or nodes added increases, the number of neighborships also increases. Okay, so you can see here, okay, 10 separate adjacencies will be required if you have 5 routers here. Okay, this leads to a considerable amount of unnecessary link LSA traffic. Okay, like why unnecessary? Like example, if a link goes down over A, okay, router A, because it is forming unicast neighborship, one-to-one neighborship with all other neighbors, all other routers on the same link, it is going to inform RC, RD, RB with the separate update packets. Then RC will inform, because there is a change, RC will inform every other router. Like that, the same information will be repeated by all the routers. Okay, each neighbor in turn would then flood the same information to all other neighbors. This is waste of bandwidth and processor load. Okay, because of this problem, okay, they have come up with this. Okay, to prevent this, OSPF will elect a DR for each multi-access network. Okay, and DR can be accessed through a special address 224.0.0.6. Okay, and there is another backup router called BDR, okay, which also can be reached through this address. Okay, is this clear? So in multi-access networks like we have here Ethernet, we have a DR per interface. Okay, so DR relation is per interface. Okay, so DR BDR relations only on Ethernet. Ethernet, or in OSPF it is called broadcast network. Okay, and it is per interface, means every interface will have a separate DR. Okay, now there are 3 rows. There will be a DR. DR is nothing but designated router. Okay, when DR goes down, BDR will take over the duties of DR. This is backup designated router. Okay, and then rest of the routers, they are called DR other. So there are 3 rows: DR, BDR, and DR other. Okay, one router will on the segment will be elected as DR, another will be BDR, rest of the router will be DR other. Okay, DR and BDR, to access them, to access DR and BDR, DR others use 224.0.0.6 address. This is the address which belongs to DR and BDR. DR, BDR, they are connected to 2 addresses. They join 2 multicast groups, 5 and 6. Whereas DR others, they join only one multicast address, 224.0.0.6. 5. Okay. Now let us see the criteria for DR election. Okay, how and which router will be elected as DR. Okay. First, case number 1. First configured router will be elected as DR. Okay. If no other router is configured for next 40 seconds, called wait timer. Okay. Whichever router configured first will be elected as DR if there is no other router for next 40 seconds. After 40 seconds, any other router coming up will become BDR and so on. The second configured router will be BDR and others will be second configured router after 40 seconds. After wait time, will be elected as BDR. The rest of the routers, DR others. Okay. So let us see case number 1. This is case number 1. So I don't have any neighbor here. Let us see. So router 1 has 2 interfaces. Do show IP interface brief. Both are in area 0. One is connected to LAN 10.1.1. In OSPF, LAN facing network is called sub network. Okay, so this E0/1 is connected to LAN where there is no neighbor. Okay, but still because it is Ethernet, there will be a DR, and that DR is called inactive DR. Okay, let us see. So I'll go to router OSPF1 interface E0/1. So router ID, let it be 11111. I'll advertise just the LAN 10.111.0.0.0 area 0 and I'll enable debug IP OSPF addressing. See here, show IP OSPF interface. Okay, network type is broadcast and waiting time. State as of now is waiting. It will wait for 40 seconds. This wait time is equal to dead interval. If you change that interval, this also changes. So by default, dead interval is 40 seconds. So wait is also 40 seconds. Now it is waiting for 40 seconds. If there is any other router during this period which comes up on the link, then there will be election. Otherwise, this router will promote himself as DR. Yeah, let us see. It is waiting for 40 seconds to expire. Now you can see once the 40-second time expires, end of wait on the interface, DR bidirection starts. Okay, this is in two-way state. If you remember, DR bidirection okay takes place in two-way state, and DR first the router interface okay elect itself as BDR. There is election for BDR. Okay, so it sees that there is no DR on the link. Okay, promote himself as DR. Okay, first the election happens for DR BDR on this link. So this router, because there is no other router, elects himself as BDR. It sees that there is no DR on the link, so promote himself as DR. Okay, is this clear, everyone? Because there is no other router, there is no BDR on this segment.
Yeah, sure.
Right. So on R1, interface already there. Okay, we have an interface 10.111/4. Okay. So only one interface, router OSPF1, router ID 1111, and then we advertise this interface area 0, and after 40 seconds, this router elected himself as DR. Okay, now you see here, show IP OSPF interface. You can see the details here. Okay, this interface use lot of information in detail. This command like network type, area, IP address, router ID, cost of the link, okay, DR, priority. We'll talk about the priority, okay, timer. Okay, so this is our DR. Show IP OSPF interface brief. Another command which is the information brief. Okay, so this is our DR. You can see the role here, state DR. Okay, this is case one. Total there are 3 cases. Okay, this is case one. Okay, and this network is connected to stub. Description. This interface is connected to stub network. Okay, so if you look here, right now this is LAN. Okay, so every for 10 seconds by default, OSPF is going to send hello packet. See, even though DR is elected, there is no other device on the link, but by default, whichever interface you advertise in OSPF, that interface starts sending hello messages every 10 seconds. You can see here. Okay, every 10 seconds they are sending hello packets, and these are the hello packets. Header information, OSPF version 2, router ID, area 0. Okay, backbone area. Authentication is type 0. No authentication means type 0 is null authentication. This hello packet contains subnet mask, priority, dead interval, okay, DR on the link. Okay, there is no BDR here, only one DR, and its capability. So it is capable of supporting external. This is the normal area. See, if you see this in a hello packet, if you see this E bit is equal to 1 and N bit is equal to 0 means it's a normal area. There are 3 types of area in OSPF. Show IP OSPF, show IP protocol. Look here, there are 3 types of area. Okay, normal area. Okay.
Yes, Sanjeev, and we just did some hack, like we just increased the dashboard.
Okay, there are 2 more types called stub and NSSA. Okay, stub and NSA is not part of CCNA. So normal area we know, okay, with this command, but how does the system knows? How does OSPF other router knows that it is a normal area? Because area type is one of the conditions for neighborship. In hello packet there are 2 bits, NSSA bit and E bit. If these bits are 0 and 1 means it's a normal area. See, there are 3 types of areas in OSPF. One of the conditions for neighborship area ID should be same, area type should be same. Normal area in hello packet, okay, there are 2 bits, E is equal to 1 and N is equal to 0 means it's a normal area. Okay, is this clear, everyone?
Yeah, exactly.
Right. One more thing you can see here is, see, sending hello packets here doesn't make any sense because there is no neighbor here. Okay, LAN means usually you have n devices connected. So we can make this interface as passive. Okay, how to make passive? There are 2 ways of doing it. I'll show both of them. One thing, like you can directly give the interface passive interface E0 by 1. This, okay, this interface will become passive and it will stop sending hello packets on that interface. Another command is passive interface default. Okay, this command, what it does, it will convert all the interfaces to passive. Okay, all the interfaces will be converted to passive, but we have a neighbor on this interface. Okay, so those interfaces on which there is a neighbor, you have to give no passive interface number. Okay, so this is our passive interface configuration. Right here, passive interface, what it does, suppress hello packets and other OSPF packets. How to do it in global configuration mode under OSPF process? Either you can type passive interface, that interface number, okay, or if you have multiple interfaces, multiple LANs, then you can use default command. All the interfaces will be turned to passive. Every interface, all the interfaces present on the router will be passive. Then whichever interface has a neighbor, you have to give this command. interface which is connected to neighbor. Okay? So here we have done, I think, already no passive, already given. Okay. No passive E0 by, sorry, my bad. Passive interface E0 by 1. Okay. No passive E0 by 0. Look here, once it interface turned to passive, it will stop sending hello packets. See, we are not able to see any packet now. Hello packets are suppressed. Okay, no more hello packets. So if you go back to the show command, okay, show interface OSPF E0 by 1. So IP. See here, no hellos. So it is turned into a passive interface. Okay. Right. So on passive interface also will be DRB DR. Remember, DRB DR has nothing to do with passive. So you can see because it is the only configured interface, it elected itself as DR. Okay, this is about the area type. Okay, normal area, OSPF area, area. And this is about normal area. Okay, this is the default area. Normal is the default area in OSPF. This is default. Okay, so this is done. Next, second case. Now we have more than one router configured. If you start both the routers within 40 seconds, okay, the router with highest interface priority will be elected as DR. Okay, every interface in OSPF, okay, has a priority of 1. Okay, every Ethernet interface will have a default interface priority as 1. Okay, so whichever router has interface as highest interface priority will be elected as DR. But the priority is default 1 only. Okay, default priority is 1. You can change it. The range is 0 to 55, and higher wins. Whichever is higher wins. Okay, if interface is configured with a priority of 0, like point to point has a priority of 0, that is why there is no election. On Ethernet links, if you configure a priority of 0, okay, that interface will not participate in priority 0 means on Ethernet
DRB DR selection will not happen.
It will become DR other time.
DR others, yeah.
Right? It will become DR other. Okay, so let us see this case. Addresses I have already configured. This is 10.25 1.2. 10.25. See, 10 is the first number I'm using. 25 router 2 to 5. One number I'm using. 2 is this interface, and 5 is this interface. Okay, case 2. I'll write here case 2. Case 1, when first configured router is elected as DR. Case 2. Okay, when more than one, okay, router is configured within 40 seconds, more than one, 2 or more than 2 also is configured within 40 seconds. 40-second wait time. This timer depends. Wait time depends on the dead interval. If you change the dead interval, this also changes. Okay. When more than one router is configured within 40 seconds, okay, the router with highest interface
ID
priority
priority.
wins. Okay. Whichever interface you have configured higher priority will win. Okay. But the default priority is 1. Default interface priority is 1. We have a range 0 to 55. Okay, higher wins.
So this interface priority thing is only valid within OSPF, no?
Yeah, within OSPF on that link. Okay.
on that link.
And yeah, interface with priority 0 will not participate in DRBDR. In DRBDR elections. Okay.
It will become
Right?
DR others.
Yeah. Then we okay. It will become
DR others.
DR other. Okay. Now, what if both interfaces are configured within 40 seconds and both have their default priority as 1 only? Okay. Then the tiebreaker is, there should be some tiebreaker, right? If the priority is same, tiebreaker is highest router ID. Okay, whichever router has highest router ID means, like we have here router 2. Okay, router 2 on one of the links E0 by 1, I think. Okay, description. See, when there is a neighbor connected on that link, that is called transit network. Okay, we are configuring here 10.25.1.2/24. Priority is default, or let us change the priority here. Let us keep this default only first. Okay, then we'll give priority on the other link. Okay, this is our interface, and OSPF configuration will be router OSPF 1, router ID 2222 network. Any command you can use 10.25.1.2 address as it is, or I can use wildcard mask also. Okay. Area, what is the area? I think we put this in different area. Okay, this is in area 1. Okay. Area has nothing to do. I want to show some more things in the same lab. That's why I'm giving a different area number here. That's it. This is the configuration on router 2, router 5 also. Same thing. I'll just look at the interface number E0 by 0. 5. You can use, I'll use here subnet mask also. If you use subnet mask also, it will save in the running configuration as wildcard mask. Okay. So let me copy this to within 40 seconds. So router 2 and router 5. Okay. This is router 2, router 5. Okay. Look here, waiting. Okay. So after 40 seconds, okay, this is in two state election. Okay, happens in two state. Okay, waiting for 40-second timer to, but this is the priority. You can see default priority is 1. Okay, now end of the wait time, election started, and you can see election is always for BDR. Remember, okay, so you can see 555 is elected itself as BDR, then promoted to DR. Okay, and then the other router 222 becomes BDR. Okay, it saw that already there is a DR, so it okay settle for BDR. Okay, show IP OSPF interface brief. Okay, this is in area 1, process ID is 1, and cost 10. This is state BDR. See number of neighbors. F means full adjacency. C connected. There is one interface, one neighbor connected, and the neighborship type is full. Okay. R5 also. This is DR. Do show IP OSPF interface brief. Okay. This is our DR. Okay, clear?
Yeah.
Okay. Now, because we have authentication also to cover, we will introduce here plain text authentication. Plain text will be better here because 4 routers are there. Okay, we'll do plain text here. See, there are 3 types of authentication: plain text and MD5. So, okay, I'll use plain text here, MD5 here. Let us. So plain text authentication I will introduce here between these two interfaces. Okay. In OSPF, okay, support three types of authentication: plain text, MD5, okay, cryptography. So let me start first plain text between R1 and between R2 and R5. Okay, authentication is also per interface. So on this interface, I have to enable authentication interface E0 by 1. Okay, IP OSPF authentication. This is the command to enable authentication in OSPF. Okay, command to enable plain text authentication at interface level. This is the command. Okay. I'll enable here Wireshark to show you the. Okay. Right now the authentication is null. Look at the header. You see simple password. Okay, I've introduced one set, right? So you can see this simple password. Authentication is enabled, but it is not showing the password because I'm not yet configured. So the password will be I'm disabling this one. You all. You all. The debug and disabling. Okay, so on interface E0 by 1 on router 2, we have introduced IP OSPF authentication. And then the password IP OSPF authentication key. Okay, give some password, appreciate key. So I'm giving here, let's say Cisco123. So this is our authentication on interface E0 by 1. Okay, this is the authentication part. Same thing I'll copy and paste on router 5 E0 by 0. Okay. Interface E0 by 0, I can copy this because same key is required and the authentication will be successful. So IP OSPF neighbor, the neighborship has gone down because one side was authentication, other side was not. Now again it has come up. Show IP OSPF interface E0 by 0. Last line will show you the authentication type out. Okay, so this is our authentication.
So this is not #5, na?
This is simple password.
Simple pass.
Yeah.
And Cisco123 is the password, na?
Password, yes. Okay, OSPF supports three types of authentication. Okay, default we already saw null. So default is type 0, null authentication. Type 0 or null authentication means there is no password.
No password.
This is default. Whatever we configure now is type 1 called simple password, where we have configured clear text password on both the sides, matching password. Okay, simple password. So for simple password between R2 and R5 on R2 interface key 0 by 1. This is one. Okay. So this is the authentication part. Okay. Let's see. And
authentication key means the password, no?
Password, yes. First the method, second the password. What is the type we are using? So we mentioned here that we want clear text, and then the password, actual password. Okay. Interface was either by zero. Okay, so here
and we are not mentioning here the type 1 or type 2, na?
No, by default. See the we are mentioning, right? This means type only.
Achha, this is type 1 only.
You have, okay, null not
type
required.
2 will be some different
command.
Na? Okay.
Authentication is per interface. Means every interface will have a separate, not per router, per interface, just like DRVD. Okay. Right. So this is done. Now we have two more segments to cover.
So DRBDR is also interface specific, Anna?
Yes, right.
Okay.
So this one we have covered. There is no DR here. Sorry, there is an inactive DR here because there is no neighbor. It's for inactive DR. Here we have an active DR. Router 5 is DR and this is BDR on this link. Okay, now this was based upon first configured. This was based upon highest router ID. Now we will make one of these router as DR using changing the interface priority. Okay, usually DR requires a router with good resources. So let us say this is our good router with good resources. Okay, see, if I start all the 4 at the same time, if I configure all the 4 within 40 seconds,
40 seconds.
then R4 will be elected as DR because it has the highest router ID 4444. Right? See what router ID we are giving. For router 1, 1111 is our router ID. For 2, 222. Right? For every router, whatever the router number, here we are configuring that as the router ID. So if we go by router ID, if all the 4 routers are configured within 40 seconds on this segment, then router 4 will be elected as DR and router 3 will be BDR and these 2 will be DR other, right?
And we never change the port priority, huh?
We are going to change now.
Okay, we will change it now.
Yeah,
Okay.
default, this will be DR, this will be BDR. These 2 will be DR other.
Mhm.
Now I want to make router 1 as DR and router 2 as BDR. Even though the router ID is less, first thing it checks is the priority, interface priority. So what I will do here, I will make the priority higher. Let's say 255. And this one 250. So this will be DR, this will be BDR. Okay? So let me configure. So I'll go to router 1. First I'll change the interface priority before configuring the command. Okay. So interface E0/0 IP OSPF priority. Okay. Anything from 0 to 55. 0 means it will not participate in the election. So I have given the priority. Okay. Next is to
250.
configure the router OSPF 1. Router ID. I will not press enter. All of them I'll press same time. Okay. 192.168.1.1 is the address of the interface. Area 0. Enter I'm not pressing. I'll start all the 4 routers same time. Okay, so that we can see election. So router, this is R2, interface E0/0 IP OSPF priority, let's say 250. And then the OSPF configuration router OSPF 1, router ID 2222, network 192.168.1.2, area.
Advertise, we are not advertising, huh? Okay.
What is it? Network command.
Mhm.
Not pressing enter. I'll press same time. Okay,
Mhm.
all the 3 I'll press same time. Router 3 priority I'm keeping default. Router OSPF 1, router ID 3333, network command. Okay. And router 4. Router OSPF 1, router ID 444.
444.
Now I'll press all of them same time. 4, 3, 2, 1. Where does it come from? Okay. And monitor here somewhere. Show IP OSPF neighbor. So it has 3 neighbors. All of them started as the election happens in 2-way state. Okay, so once they reach extract, there will be DR already elected. Okay, first router will become DR. 40-second wait time. Once the wait time expires, then the election starts. See, when they reach extract state, you can see this router is elected as DR. Highest interface priority wins. BDR. Okay. Now see here, I am on router 3, which is DR other. Show IP OSPF interface brief. Okay, this router 3 is DR other. It's role DR other. There are total neighbors, 3 neighbors. Connected neighbors are 3. Out of them, full it form adjacency with DR and BDR. Okay, see, R3 has adjacency with R1, which is our DR and BDR. Okay, with R1 and R2, both are DR and BDR. So with DR and BDR, DR other will maintain a full adjacency. Whereas with other DR others, their neighborship is, you can see, up to 2. They are just neighbor. They're not adjacent neighbors. Okay, is this clear?
Okay, so that means if there is a BDR and DR, I mean all the other DR others will make full adjacency with them,
Yes.
And DR BADR also within them will make full adjacency, hai na?
Yes, right. If I go
Okay.
to
And within DR others, it is only two-way.
to IP OSPF
Uh-huh.
interface brief. This is on DR, so this is the segment. So you can see 3 out of 3 neighbors full, because this is DR. So DR maintains full neighborship with all.
With all, okay.
Okay. So
And BDR?
BDR also same. Full, all.
Okay.
Okay. You can see full neighborship on the segment. Okay. DR others also with BDR also. Same thing BDR also. Do show IP OSPF interface brief. So on this segment E0 by 0 in area 0, 3 neighbors, all 3 are full. Okay. Do show IP OSPF neighbors. Okay. This is for area 1. Okay, leave it. Other interface. This is our segment. So you can see it is okay. Full neighborship with everybody. Whereas if you look at DR others, between 2 DR others, it will be two-way.
Two-way only. So just to revise the things, if I'm correct, Shaq, like the DR BDRs actually have full adjacency built between others and as well as within them also.
BDR also,
So
yes.
that means like not only the hello packets are being forwarded.
Hello packets are sent to every see. Hello packets are sent on 224.
But also the LSDBs are also being forwarded, huh?
Yes, yes. Full means everything.
Full
Hello
means
packet
everything,
plus
and if it is not full, it is two-way only. That means the neighborship is found, but not the adjacency,
yes,
and only the hello packets are being sent.
Yes.
No LSDB thing, na?
No LSDB. They will, like these two will not exchange directly LSDB. Whatever they have
So
to, they have
this
to
is the
send DR.
significance of electing the DR and BDR.
Yeah, yeah. To reduce the number, LSA flooding. Right?
Hmm.
Okay. So let us see. Let me write down here.
And one logic also, why on I mean what we call on Ethernet interfaces it is done,
Because Ethernet supports more than
not
one.
on the point to point.
The reason, see, on point to point there is no third router, so they have to communicate directly, right? The flooding will be done between. They are known to each other only. Okay, whereas here there is the possibility of more routers. As the number of routers grows, the number of flooding also increases. We have seen just this, right?
Got it. Yeah, got it.
If interface goes down, every redundant information, every router will give the same information again and again.
Got it. Got it.
Right.
Here there is no possibility in serial links.
Because there are only two. Okay, so they will exchange directly. Okay.
So in that case, DRBDR is not relevant. Huh? They will always
there is no
make
DRBDR
adjacency
because
and I mean they will not be called as DRBDR.
Yeah.
However, they will work as if they are DRBDR, na?
They are going to exchange full neighbors.
full name, full database. Got it. Thank you, Ashok. Yeah.
The third case, okay, let's. Okay. Brings here, not participation. So what we did on router, all the 4 routers, one interface each, we can say R1 is our DR. So on interface E0 by 0 IP OSPF.
When more than one
router is 55. Router OSPF 1.
So this is case 2, na? What the difference between 2 and 3?
2 is based upon
within 40 seconds, na?
Everything is within 40 seconds, but router ID. Priority was same here.
Okay.
Was
Tiebreaker was RID. Okay.
So
now we will change the port priority. ठीक है.
10 dot. Oh, sorry, 192. 192, 168, 1.1 area 0. That's it. This is router 1, our DR. Router 2 BDR. So
2.
router 3 is DR other.
2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2.
no priority. Router 3 and router 4.
So Ishak, I mean, while we are designing or deciding that, I mean, okay, out of these 4 routers, R1, R2, R3, R4, we should make R1 and R2 as DR and BDR. I think we should like their reliability should be considered, na? If
Yeah, of course, yes. That's why the router with good resources, okay, should be
resources as well as
as
because they
the
have more work to do, na?
yes, that's right. Okay. The router with better resources, the good hardware should be picked as the
DR
DR.
and BDR.
So this is R1, R2 is also similar. So R3, this is our DR other. On DR other, it will look like this. DR BDR, you see this part type. Okay. Then okay, right? So DR, now one thing, DR and BDR, okay, maintains full adjacency
Full adjacency.
with everyone, with
Everyone.
everyone. Okay, DR, BDR, or whatever. Okay, DR others, between DR others,
Between the others. Only neighborship, huh?
between DR other, okay,
No full adjacency. Two-way, huh? Two-way, two ways maintained.
two-way neighborship, right? It's a neighbor only.
It's neighbor only.
It's maintained. Okay, it means they cannot exchange direct information.
It's maintained.
Right now, DR and BDR, when they have to send their updates, okay, sends update and acknowledgement on this address so that everybody can receive.
5. Okay.
Hello packets.
Updates and acknowledgements.
Hello packets are sent
on 5 only, na?
5 only. Everyone send on 5. All routers DR, BDR, or whatever. DR, BDR,
The others.
DR others. They will send on 5 only. Hello packets. Okay. Whereas updates, okay, for updates and acknowledgement, they use different addresses. Updates and acknowledgement. Okay, DR and BDR sends their update as well as acknowledgement on 5. DR others, okay, sends updates and acknowledgement on 6.
Updates and acknowledgement. This is not hello packet, na? No.
No, yeah, this is not hello. Right? I'll show that. Okay, let us see.
No, what is the meaning of that? Please, can you explain?
Update means I'm advertising on network. I'm going to do this now. Okay, on DR other. So DR other will send an update packet. Okay, there will be source of that address, right? Source will be the interface IP. 192.
Suppose there is another router is connected with R3. Suppose on the left hand side.
No, maybe a LAN, not necessarily.
Okay, maybe a LAN also.
LAN, okay, a LAN is connected here. I'm advertising that LAN on the segment. Okay, the source IP is 192.168.1.3, the IP address of this interface. Destination IP 6, and then the update packet 333332, whatever it is, the metric value, all these things. Okay, so this will be sent on 224.0.0.6 by R3. This will be received by DR and BDR, not DR other. Same packet now DR will take. Okay, whatever exactly same packet what DR does, it will forward to everybody on 5.
Okay,
now when it
because
to 5,
this is its job
receives.
actually. This is its job to circulate.
Yes, everybody, all DR others will receive now. Because OSPF is reliable, everyone has to acknowledge. Okay, when R1 and R2 receive the update from DR other, they will acknowledge on 5. Same address.
Whereas, and R3 when receive update or want to send, it will send at 6, na?
6, yes.
So that it is only received at DR and BDR.
Yes.
Okay.
Let me show this. Yeah, I'm going to advertise one loopback. I have a loopback. Loopback means some line here. to IP OSPF interface LAN. Okay, some LAN I'm advertising. To IP interface 3333. Look here, I'm advertising it. Router OSPF 1 already advertised. Just other things are configured. Just advertise 3333 area 0. Okay, see here. And update will be same. See. R3 with the source IP interface IP of 192.168.1.3 sending an update. Let's update the packet on 5. Look at the update. Okay, this is the OSPF packet, ls update packet, type 1 LSA default, and this is your information. 333 loopback, metric 1 for loopback. Same thing, DR, 11 is DR, same information it is sending to everybody on 5. Look here. Same update packet sent by exactly same information. DR is sending to everybody. Right? These are the updates. So you can see DR other sensor update on 6, DR and BDR on 5. Now look at the acknowledgement. This is BDR. BDR is acknowledging on 5. Right?
Acknowledging on 5. But the
And
acknowledgement was supposed to be sent only to the router which sent it the update.
DR, BDR can speak with everybody, right? So okay, directly to send 5, everybody will receive it.
Okay.
Okay. Whereas if you look here, 6, router 4 is DR other, it is sending acknowledgement on 6. Okay.
No, could you come again, please?
Yes.
This 5 and 6, the row number 21. 21 is for which?
BDR.
BDR is acknowledging. BDR is acknowledging the update which was sent by R3.
BDR. No, send by 1. 3 of, you can say 3 of, correct. It receive at that time itself. Okay, so it is acknowledging on 5 because see on what address they are receiving the update.
On what
they know
address?
Only 5. They know only 5, right? See, if you look at R3, do show IP interface E0 by 0. Okay, they join only one multicast group. Okay, if you want to tell them, see, update is sent by R3. So how does R3 comes to know that the update which is sent is received? Through 5 only, right?
Because they do not understand 6.
6 there. Okay, whereas DR or BDR to IP interface E0 by 0, they join 2 multicast groups. 5 and 6.
DR and BDR, huh? But this is R3's only. So the other routers will also receive that acknowledgement. Will not receive. I mean, not what we call it. Will discard it, na?
Which one?
That acknowledgement. Other routers will also receive.
Yeah. See, this suppose this acknowledgement sent to 3x.
No, if R1 is actually sending the acknowledgement to R3. Okay, that I have received
R3 will accept. R3 will accept, right? Because R3 is the one who sent.
But it will be received by R4 and R4 also, na? So they will discard it, na?
Yes.
Okay. That I was actually trying to confirm. Yeah. They will discard it.
Yeah. Okay. Right. Now, what happens if DR goes down? Okay. When DR goes down, only BDR can become DR. Let us do that on R1 and shut down the interface for a while. Interface E0 by 0, which is our DR, is set now. In 2 cases, DR will lose its role. One, when the interface goes down. Other thing, when you set the priority to 0. If you join the priority on DR to 0 on this interface, immediately it will give up its role. It will become DR other. Okay.
Yes.
So when DR goes down, okay. So when DR goes down, any of the method goes down, BDR will promote himself as DR.
As DR.
It's promoted to
DR.
DR. One of the DR other will become now BDR.
BDR.
Okay. One of the DR other will become BDR based upon the same criteria. Okay, highest router interface priority followed by highest router ID. Okay. So highest first they look at interface priority. If that is same, then
highest router ID.
Router ID. Okay.
Got it.
And now when the DR comes back, the former DR Okay, we have not shut down. Now let me shut down. Okay, so this one will become DR. You can see here. Okay, because OSPF dead interval 40 seconds, the routers are waiting for this timer to expire. After 40 seconds only, the failure will be detected. In normal scenario, it takes 40 seconds to detect a neighborship failure. Because it stopped receiving hello packets, so 40 seconds it will receive. Wait, after 40 seconds, you can see R1 will be removed from the neighbor table. 222 will become DR. See here, 222 is DR and R4 is DR other. I go and type this command here, do show IP OSPF neighbor. I am on DR other. So now 222 is my DR and 44 has become BDR. Okay.
Depending on neighbor ID.
Yes.
Okay.
Yeah. Next, let's say this DR comes back. It has the highest priority, right? So there is no preemption here. Once gone rule, okay, it has to settle for DR other. Look here. Now our former DR makes a comeback. Okay, it sees that already there is a DR in the network, BDR is also present, so it has to settle for DR other, even though its priority is higher. Okay, if you want to make them again DR, you have to clear the process on all the routers.
No, this is not clear, Ishaq, please. If DR others, if the DR, router 1 becomes
What
available
DR?
again.
See, this was DR, it went down. Okay, so when DR goes down, BDR becomes DR. Only
DR
BDR
becomes
becomes
DR.
DR. Okay, and one of the router from the remaining DR others become full BDR. Now, this router 1 is making a comeback. Whatever is address, it is making a comeback. So when it makes a comeback with the highest priority, it sees that already there is a DR and BDR in the network. When the DR and BDR is already there, then only one role is left for that router. So it has to settle for DR other.
Okay, so it will keep on becoming DR other only.
DR other only. Yeah.
Although it has higher priority, highest priority.
Yes. Now, if you want to give the role back to the router,
it will not capture it automatically.
Yes,
The role of the DR.
Yes, you have to process it. Yes.
Okay.
Okay, you have to clear the process on all the routers. Okay, so like do clear IP OSPF. This is the command, or set all the interface.
So Ishaq, I mean, don't you think this might be a question in the interview?
Yeah, of course.
Like,
These are all
they can say like, I mean, if even the priority is high, even then it is not DRY.
Yeah, that's possible. Another possibility, you have configured it already. When you configured with higher priority, there was already DR and BDR in the network.
Yes.
Okay. Here I'm starting all the 4 processes. Let's see. Router 1. See here, R1 is again SSGR. So this is the one. Update is done. Now the next part is we have MD. Okay, let us see no election on this link. Okay, because point-to-point link there is no election. So here, along with the neighborship, I'm putting this in some other area 2. I'll enable here MD5 authentication. Okay, in fact, okay. MD5 also there are 2 options. Let us start with MD5 first. Okay, between these 2 routers. So I'll go to router 6 first. Okay, this is the interface.
as 0.0.
Router OSPF1, router ID 6666, network 10.46.1.6, area 2. I'm enabling authentication of OSPF authentication. See, I'm enabling authentication at
We are putting it in area 2 because within one area we can only choose one type of authentication. Is that right?
per area, yes.
Yes. Okay. Within one type of area, only one type of authentication is
Yes.
applicable.
Yes.
Okay.
IP OSPF authentication. Not OSPF, sorry. Command. Area 2 authentication. Okay. We can enable authentication at global level. Okay. Means all the interfaces now will be
In area 2.
area 2. In area 2 will be MD5 authentication. MD5 authentication we are enabling on all the interfaces on router. Right now we have only one area. Okay. So we enable MD5 authentication in entire area. Okay, with this command. Then the password you have to give at interface level only. You cannot configure password globally for every interface. Okay, separately. So IP OSPF message digest key 1, some number, key number, any number you can use, I'll use 100, and then MD5 algorithm. Okay, password. This to let's say 456. This is our MD5 authentication on router 6. Okay, this is the password. Okay, now on R4 I will configure interface level. Okay, because R4 is connected to other areas, I cannot configure. Okay, so what I will do here, interface S2 by 0, IP address already there, IP OSPF1 area 2, IP OSPF authentication message digest, IP OSPF message digest key 100, and
Here we have to put authentication command to a interface only.
interface level, yes. Okay, and what is the command? Message digest key MD5 Cisco
456.
456.
So basically R4 becomes an ABR, huh?
Yeah, it's there, yes. So cryptographic authentication is enabled. Okay, it will carry the password as a cryptographic message.
And encrypted. Okay.
Under header cryptographic, and this is the password. Sequence number, password, key ID. Okay.
Got it.
Right. We'll make a note and okay. Give me 5 minutes. We'll start. Okay, after 5 minutes.
Okay. 11:36. Huh?
Hello.
Yeah, Ishak.
Yeah, let's start. So we have done the DRBDR also is done, right? So, and DR goes down already. Okay, we have done cryptography. Okay, cryptography. Okay. Type 2 authentication between router 4 and 6.
Right.
So R6 interface is 2 by 0. Okay, we enable authentication on this router globally. Area 2, and then we enable authentication globally. The authentication can be enabled globally or interface. If you enable globally, all the interfaces on that area, okay, authentication will be enabled. Okay, so this is globally enabling authentication, but password you have to give at interface level only. Your password cannot be configured at global level. So this is our password. On R4, IP OSPF 1. Okay, we are advertising at interface level and authentication here. To confirm, the command is show IP OSPF interface. Last line of the command, you can see the information about. Okay, this is the last line. So show IP OSPF interface. Yeah, and let us see section will work. Section cryptography, not working. So begin, I will use begin. It will show the output from beginning from CRY, whatever you type here. Begin means from it will start the output from here. Okay, so this is our authentication. Okay. Clear?
Yeah, clear.
Now we have one more router here. So what I will do here, then I will discuss about LSC type after this. Okay. We have another router here, router 5, which has a link connected to internet. Let's say this is outside network. Okay, so this is going to be our SBR. Okay, so there is a link here connected to internet. So I'll get one address from internet. Here, interface E0 by 1 of router 5 is connected to internet. Config T, interface E0 by 1, IP address, the here description, connected to internet, IP address DHCP. You get one address from the same range as our GNS. In GNS, we have a pool that will assign us address from the same range. Okay, one address will get, and also you get an access to the internet. Okay, let us. Okay, you can see we receive an address, show IP interface brief. Okay, this is the address we receive from DHCP. Okay, along with the address, see whenever I told before also, whenever a router or a multi-layer switch or a firewall interface is configured with DHCP, okay, it will get one address, along with the address, a default route will be installed in the routing table. Okay, with a AD value of 254. How to differentiate it with a normal default route is the DHCP default route will have a AD value of
254.
254. Okay, but there is one more command on GNS, show IP OSPF, show IP static route. Static route. If you type this command, it shows the type also. Like this is D stands for DHCP. Okay. Now this router 5 can access internet, like 888 is Google. Okay. Or if I enable IP domain lookup, I can use DNS names also, like doping disco.com. Okay, anything I can ping, doping,
Google.
Facebook.com, Google.com, anything, whichever you want. Okay, so router 5 has access to internet. Okay, but other routers they don't have. If you want, let's say this is your head office and you want other also to use the same, like suppose example internet. Yes, suppose we have here firewalls in this area, or maybe this is data center where you want security, because internet means you are accessing the outside world. Here this is involved, so you want everything to go through the security channel here. Like you have put IPS, IDS device, proxy device, all those security related devices, and you want anyone who want to get access to the internet should go through those. Okay, security. So here what we can do, we can redistribute this route, okay, static route into OSPF. Okay, we can send this route, then only it will become ASBR. As of now, it's not ASBR, it's a normal router. Okay, to make it ASBR on R5, we have to add this route. Okay, there is only a single line command for that. Default information originate. This is part of the syllabus. Okay, default information originate. What this command does, okay, if you already have a default route present in your router, like we already have here, it will redistribute that route into OSP. Okay, if you don't have, also you can generate one by using the keyword always, which is not required for us because we have a default route already present. Okay, so what R5 does now, it redistributed this default route into OSPF domain. So if you go to any router now, like R1, any router, and look at the routing table, you can see here E2 external route, the default route. Okay, now is redistributed as a OSPF route. So R1 now can access any network which we have ping this. Okay, so it has reachability 888. Okay, so all the routers now they have access to the internet. Okay, show IP route, OSPF active. Okay.
Okay, so that means on that ASBR, we will just put that command and it will start redistributing.
It redistributed that default route into OSPF.
Default route. The complete OSPF area.
Domain. Yes, complete domain. Okay. Now, what else you see here? R1, you can see in R1 there are different types of route. O means same area. 333 is O, so same area route. OIA means other areas. Okay, like 25 is other area. This is other area. So 25 and 46 you can see as other area route. The cost is the cumulative cost. Okay, for default route, it will be only one. Wherever is a fixed cost.
So area 1 router will also be able to reach to internet.
Everyone, or throughout the domain, OSPF domain, complete domain.
Complete OSPF domain.
Yes.
Okay.
Okay.
Because area 0 routes are also getting advertised to R1 area 1 also, na?
Yes, yes. All areas will receive. Okay, even RC. Okay. Those two IP route OSPF will receive the default route. Okay. Other areas Y.
Got it.
Okay. So this is our default route. Now the last part is LSS.
Okay. Ishak, before that, as we saw building the neighborship and all for Ethernet, should be just focusing the same thing or the serial link also?
Serial is nothing. See, serial we have no DR, right?
No DR, BDR,
so
only hello packets.
Hello packets. With
And
hello
also
packet,
the LSDB, the complete LSDB also.
yeah. See, on Ethernet there are two possibilities: either two-way adjacent neighbors or fully adjacent neighbors. Whereas point-to-point always fully adjacent neighbors.
So
Okay.
all those I mean what we call them, um, um actions will follow like the two-way and full and all
Yeah.
in it.
Go through the
The
steps.
complete
Yeah.
the complete states will be
Yeah.
done.
Yes,
Okay,
sir.
okay.
Let me show you. Okay, what I will do here. How do we advertise? Let us see. Will show run. Okay, I can show you here. No problem. Router OSPF1. Yes, I think in last class also I showed this one. Okay, this is the command to see the output on the screen. Okay, see, we have point-to-point connection between R4 and R6. Priority 0, point-to-point has a priority of 0, and there is no state rule here. Okay, all full and dash. Okay, see here, I am shutting down the OSPF process and restart again. Okay, we shut down the OSPF. Okay, now the neighborship is broken. I'll restart the. Okay, let us see whether this is removed here also. Show IP OSPF neighbor. So R6 will be, this is R6. Okay, neighborship is now down to init only because we shut down. Okay, now I'll no shut this router R6. We shut down the process and no shut. Here down to init to two-way to extract to exchange to loading to put. This applies for all the types of OSPF neighborship. Okay, point to point or Ethernet. Okay, but election happens in two-way state because there is no election here. Immediately they move to. There is no 40-second wait in point to point. Okay?
Yes.
Immediately, so you see even here I can change the type to point to point. Mostly this is what done in real time. Okay, when you have Ethernet, just two interfaces connected. There is no need to go through wait for 40 seconds.
Got it.
Okay, so you can change this type to IP OSPF network type point to point. Okay. Then there will be election. There will be no election. Or, okay. No. Yeah, there will be election will be there, right? But 40-second wait will not be.
Okay, so you are saying that, I mean, in order to zero to make that
Yeah,
amount
40-second time, yes.
that weight is 0. Okay.
Yes.
We can make point to point,
Point to point, yes.
just for that purpose only. Otherwise,
Yes.
it will behave. I mean, adjacency and DRBDR
Same
election
thing.
will happen.
Same, yes.
Okay.
Right. This is done. Then what else we have? Okay, LSA types. See the difference between point to point. Remember one of the conditions for neighborship, network type should match. OSPF, suppose one side I am using point to point, other side I have configured broadcast. Okay, one router we have point to point, other router broadcast. Then neighborship will come up, but because in neighborship, if you look at hello packet, they are not looking at the network type, right? If you see any hello packet, it shows the timers and other things, but it will not show you the network type. So they will become neighbors. Okay, but the problem is they cannot exchange the database. Like R1 we are configured point to point, R2 let's say broadcast. Okay, they will become neighbor because in hello packets neighbor type is not exchanged. But in extract state, okay, they will exchange DBD packets.
Could you please again? This is like point to point and broadcast. These are the two different type of networks.
Right. Yes. We see one of the condition. If you remember, we have one of the 10 conditions for neighborship. Their network type should be same. What if you configure different network type? They will become neighbors. Why they will become neighbors? Because in hello packets, what are the values they check? Area ID, right? Area type. These are the things which we are checking. Hello
So
interval.
it means on R1 we have configured point to point, and R2 we have configured broadcast.
Okay, so that part is not checked in the hello packet, so they will become neighbors. Okay, but they cannot exchange database. They cannot exchange database. Reason point
adjacency will not be.
No, just I'll tell you. To become adjacent neighbors, you have to exchange database, right? In point-to-point network, there are 5 LSA types: LSA type 1, LSA type 2, LSA type. Sorry, LSA type 2 is there in Ethernet, not here. Okay, this is not there. Okay, so here we have 1, 3, 4, and 5. These are the LSAs required to build the database. Okay, point to point has these LSA types. Whereas Ethernet, which is broadcast, has one more type, type 2. Type 2 is generated by DR. So there is no DR BDR in point to point. Okay, so this will be missing. So the database is different. So you cannot build the topology without the complete LS information. That's why they will become neighbors, but they cannot exchange any database information.
Because in P2P, LSA type 2 will be missing.
Yeah, missing, yes. So the structure will not be same. Okay. Now
Hmm.
let us see these LSs, what these LSs are. I will start with serial. Okay, anything you can start with. Because LSA type is on every router. Do show IP OSPF database in the command. So you can see here we are able to see 4 LSs. Okay. This is LSA type 1 called router link state, type 3, type 4, type 5 on point to point. Whereas if you look at broadcast, okay, there are 5 LSs. LSA type 1, type 2 generated by DR, type 3, type 4, and type 5.
So do we
Okay.
have to remember these types, no?
Yeah, LSA is up to type 3 is part of the syllabus. Very simple, I'll explain that. See, if you look at the headers, they are same. Everyone has link ID, advertising router, age. As I told, age when a router reaches 18 minutes, it will send an update. Sequence number, when an update is added, this number will increase. Checksum for integrity, number of links in that router. So every router will generate one LSA type 1.
Can you please copy paste until 3 in the notepad?
Yeah,
Please?
yeah. Until 5, I'll copy.
Okay, yeah, please.
Those two are very simple. Okay, very simple. Okay. So
Okay.
try to understand them very simple. First, we'll start with LSA type 1. Every router generates LSA type 1. Okay. It will give information about that router, whatever the interfaces that are typed in that area. Like here, for every area, there is simply a complete different LSDB. So ABR, you see two two databases, one for area 0, one for area 1. Here, area 0 and area 2. Okay. So let's start from here. Router 1 has 2 interfaces in area 0. So you see here number of links 2. Whereas if you look at router 6, it shows in area 2, it has 2 links. Because as I told, on point to point link, there is no type 2. So these routers will validate each other. Now let's do this in detail. Look at this type 1 LSA, do show IP OSPF database. Type 1 LSA is called router LSA of router 6 we are seeing. Okay. So if you look here, this is LSA type 1 on router 6. It says advertising router is router ID, link ID is also router ID in type 1 LSA. Number of links 2, even though there is only one single link. If you notice here, the first one LSA is validating the neighbor. Link connected to another point-to-point router. Neighbor router ID is 4444. This is the router 6 own interface ID. Okay, and this is the interface advertisement. Okay, so two LSAs are there. One for advertisement network command, other for validating the neighbor. So on point to point, there will be two LSAs. Point to point will be counted as 2. Every link of point to point is considered as 2 links because neighbors are validating each other. Right? Whereas if you look at R1, it shows because it is Ethernet, 2 links. Okay, show IP OSPF database router 1111. In area 0, this is the LAN. Okay, this one. This is LAN. Okay, 1011 stub network it shows connected to stub network. One link. Other link connected to this segment. Because there is a DR here, it is called a neighbor present. It is called transit network. LAN is called stub network. LAN or point to point is called stub network. Whereas when you have more than one DR, when there is a DR, it is called transit network. Okay.
And every link will be considered one only at Ethernet.
Only one, yes. Okay? So you can see 2 links. Okay? But this is LSA type 1. Okay. This is called LSA type 1. Link ID in LSA type 1 is router ID. Advertising router is also router ID. Age you already know. Sequence number as the database keep changing, this number will increment. This is for integrity, okay, update integrity, and this is your database integrity, and this is your number of links. Okay, so all the LSA structures are same except type 1. Type 1 will have extra link count. Other LSAs will not see link count. Okay, there is no link count in other LSA. So this is your type 1 LSA.
But Ishak, I mean, type 1 LSA, type 2.
Type 2 I'm coming to. First
No, no.
understand type 1.
No. What I was asking, just go to there. JRS. So here, I mean, all these things are very same. I mean,
Just see
you know,
database.
those fields are link ID, advert. So what is the difference between these?
See, every router has identical database in OSPF, right? We discussed LSDB synchronized. Okay.
So NAT link state. Okay, this is router link state. This is NAT link state. This is summary NAT link state.
We'll know about it. There are some differences.
Okay.
First, understand this. This is for
router link state. Okay.
LSA type 1 or router link.
Router link state.
Link state. Okay.
What is the state of the links on that router? Huh?
Yeah.
Okay.
State. Those states. Okay. Every OSPF router generates this. Okay. Every OSPF router, whatever role it is, DR, BDR, point to point, DR other, point to multi-points. Point to point, point to multi-point, NBMA, whatever. Okay, NBMA, whatever the network type, generates one LSA type 1. Just one. Yeah.
So in point to point, we do not call them DR others. Huh?
Just the point to point is point. There is no name, right? They are called point to point only.
Okay, so DR, BDR, and DR other are only applicable at Ethernet only. Okay,
yes.
Okay.
So this router generates one LSA type 1. Okay, one LSA type 1 LSA. Okay, and LSA type 1 cannot cross the area. The scope of the LSA is within the area. The area
within that area. Okay.
Yeah, within that will be flooded within the area. Okay, and this is the information it carries. Link ID, router ID, advertising router ID, age, sequence number, checksum, and number of. This is the extra information it carries in compared to others. Okay, so this is your LSA type 1. And if you look at detail, to IP OSPF database router, you just type
data.
Whatever router ID, you will see the detail. Database missing, yeah. Okay, it uses the detail like cost. Okay, subnet mask, slash value, everything in detail you'll see with this.
Okay, so show IP is data router 1111.
Yes.
Okay.
Router ID. Show IP OSPF database. If notice it, everybody.
So it will give only the first
LSA type 1.
LSA type first only. Okay.
All the routers LSA type 1 will be displayed.
Show IP as data router. If we are not database router, if we are not giving the router name, then only it will be okay.
All on the link.
For all the links or the interfaces.
All type 1 LSAs on the router. All type 1 LSAs.
All type LSAs. Okay. Yeah. Corresponding to all links, all interfaces, na?
Yes. Show IP OSPF database will give a summary. Show IP OSPF database router will show you only that particular, all the LSA type 1
router ID.
Want the router ID for one particular. Then we have LSA type 2. LSA type 2 is network link states. So this is generated only by DR. DR generates LSA
type 2.
And again the scope is
within area.
Within that area, within the area. So area type 1 and type 2 cannot cross into other areas. Okay, so this is here we have a DBA show, I mean DR. Okay, 111 is DR in our network. Okay, and if you want to see the detail, the IP address link ID is not router ID here in question. Link ID is the IP address of DR. So the difference between the two LSAs are, in type 1 LSA, link ID is also router ID, advertising router is also router ID. Whereas in type 2, link ID is the IP address of DR. Okay, so in here, we have R1 E0 by 0 as our DR. So if you want to see the details, show IP, OSPF database, network link. Okay, see here. This will validate all the neighbors. Okay, it will all the routers attached to the interface, their subnet mask. Okay, so this is LSA type 2 validating all the neighbors. Okay, with one LSA, it is validating everyone present on this segment. Okay, so this is called LSA type 2. Okay,
and the command is network. You have to add the keyword network here. Okay,
show IP OSPF network is the command.
Instead of database, we have to put network.
Database, of course, data net. Data after data.
Okay, database. Okay, network.
Database command, and this is the sub command. Okay. Okay, and it validates all the neighbors on the link. The third type of LSA is called summary ESB, summary link state. Sorry. See, this is generated by ABR. ABR generate. This is OIA routes, nothing but OIA route. Type 1 is O routes. Type 2 is DR information. Type 3 is OIA routes. Route learned from one network, one area will be injected into other areas by ABR. So if you look here, 1025 is known to area 0 through ABR. So this is the one, type 3. Okay, they come to know about OIA route 1025.1.0 through ABR. Also, we have another area, 444 is the ABR here. So 1046.10 information is done by area 0 through ABR. 555. Sorry, 4444.
So in case there is no ABR,
then there is no type 3.
There is no type 3, no?
Yeah. Within the area, we have only type 1 and type 2. Okay, this is for multi-area network. Type 3, LSA type 3 in multi-area configurations. Okay, type 3 onwards, everything is multi-area. Okay, so in multi-area configuration, LSA type 3 is generated. Okay, so LSA type 3.
And it will cross the areas, huh? Definitely.
Yeah. It is for sending information to other areas. Okay, so this is generated by ABR. ABR generates LSA type 3. Okay, and ABR injects networks from one area into another area. Network or routes are right. Okay? Routes from one area into another. Okay, this is ABR. So here you can see the advertising router is ABR, and this is the OIA routes. Okay, if you look in the routing table, this route will be displayed as IP route OSPF. This is OIA route. Type 3 LSA. Type 1 LSA is O route. Type 3 LSA is OIA. Type 5 is E route. Okay, now two more LSAs. These three are part of exam. Type 4 is very simple. Let us see. Type 4, type 5 very easy. Okay. See here.
What is the command for type 3?
So IP, see, for everyone the command is same. Okay. If you want to see router,
and if the detailed thing, na, that we put like a database network and something like that, na?
Yes,
summary. Summary. Okay.
Summary. Yeah.
Show IP versus summary. Okay. Instead of network, it is summary. Okay.
So this is our DR.
Got it.
And ABR is informing them. Okay. Then
fourth one.
Type 4 OSPF database ASB it is called, or we first look at the detail. This is our LSA type 4. Okay. See, type 4 is generated to inform other areas the presence of ASBR. We have an ASBR in area 1. Okay, this area is aware of ASBR because internally they use type 1 to inform each other. Okay, through type 1 LSA, routers in area 1 will know about ASBR. But other areas, how do they know about ASBR? So here is where ABR will inject type 4 LSA. Okay, type 4 LSA contains only the router ID of ASBR, nothing else. Okay, it just contains the router ID of ASBR to inform them that in our area 1, so area we have a ASBR. That's it. Okay, the message is only to inform other areas the presence of ASBR. Okay, so interview question can be or exam question can be whether type 4 is generated within the area where you have an ASBR. Okay, so the answer should be no. Type 4 is not generated in the area where you have an ASBR. Okay, type 4 is generated to inform other areas about ASBR. Okay.
Okay.
Right.
So that means within that area 1, it will not be.
Yeah, because they know each other, because they know through type 1. They know through type 1 LSA. Okay. So type 4 LSA type 4 is generated by ABR again.
Yes.
By ABR to inform
that I have an
other
ASBR.
areas, yes. The presence of
ASBR.
ASBR. Okay, and ABR advertise ASBR router ID. Only it carries the router ID. Type 4 carries router ID. One important point here is you have to remember type 4 is not generated
within the ASBR area.
In the area where ASBR is present.
Okay.
If you look at the database of this area R5, okay, you go to R5 and check the database, do show IP, OSPF database. See here there is type 1, type 2, type 3, no type 4. Okay, type 4 will, because these routers knows about this area, this ASBR already here, right? They know the router ID in type 1 itself. This is type 1, so no need for another LS. Okay, because the other areas, see, other areas are not aware of ASBR in type 1 LSC, type 2, still here there is no information, right? In type 1, type 2, type 3, there is no information, 5555. Now they come to know that there is an ASBR, right? Now look here, because all of them already knows that there is an ASBR, when the default route is generated, they will accept. Okay, through LSA type 5. This is your type 5 last LS, external LSA advertised by ASBR. See who is advertising this? Directly ASBR.
So Ishak, just one thing. Can you go to GNS, please? In the background. So you are saying that like ABR will not receive type 4 because it will understand the presence of ASBR within the by type 1 only.
Type 1 LSA.
But I think I mean in that case, like how come ABR will know that it is ASBR or a normal router?
There are some bits to be set. There are some bits are set here. Okay, there will be bit called ASBR bit. That bit will be set when it's in the update.
Okay, in the updates
bit,
only.
Type 1 LSA only.
Okay.
In type 1 LSA, bit will be set to inform. The same thing ABR also. How does they know about ABR? This outer scope for NA. Through one bit will be set to the ABR bit. There is a bit called ABR.
And that will be sent in the updates.
Yeah, update, yeah. ABR bit is equal to 1, ASBR bit is equal to 1.
0, 1. One means when it will be coming from R5, huh?
Yes.
Okay.
So within the area they know by type 1 LSA, but other areas through type 4.
So when Ishak, it is already been communicated via the help of this setting up this
but
bit.
Yes, see, but how does these areas know? See, type 1 is within that area only, right?
Yeah.
I can send type 1 from one area into another area. It has to be a type, some other type, right?
Because we have to send it in the different area.
Yes, type 4 is it. Okay. And finally, type 5, LSA type 5, external LSA.
Like DHCP, huh? Coming from internet, something.
No. anything, internet or redistribution through EIGRP, some any network, right? ASBR.
Okay. Okay.
And this is called
Generated by
external,
ASPF.
external link state.
Mm.
So ASBR is advertising default route. If there is some route, EIGRP route or other routing protocol also will be coming in type 5 only.
From different
ASBR.
asynchronous system, huh?
Yes, different ones.
Okay.
Yes.
Autonomous, sorry, autonomous system.
Yes.
Uh-huh.
So LSA type 1 router ring, okay, advertised by all routers, advertised by
All routers within the same area.
okay, within same area, and route wise O route, right?
O route.
LSA
Okay.
type 2 generated by DR.
By DR only, huh?
DR. Okay.
Within the same area.
Within the same area. Within same area to validate the neighbors present on that link.
Huh.
Okay. There is no route for that. Then LSA type 3, okay, generated by
ABR.
ABR. Okay. Injects
Across areas.
okay,
Injects
OIA routes
OIA routes
into other areas. From one area into another. From into another. Okay. Then type 4.
From ASBR.
No, again type 4 is also ABR only.
ABR only. But that was type 5.
ABR. Okay. Informs other areas the presence of ASBR.
ASBR.
Okay.
Achha.
Right. Router ID sent. Router ID of ASBR. Okay, this is what it carries. And then finally type 5 is external. External generated by
ASBR.
ASBR.
Advertising the other autonomous system routes. External routes.
Like E1, E2, all N1, N2, all. Sorry, even E2, sorry, even E2, no N1. Okay.
And
so
what is type 4 called? Routes?
There is no route, right? Type 1, type 3, type 5 has route. Alternate, okay. Odd
2 and 4 don't have. Okay.
2 about DR and 4 about HBR.
Okay. And until unless DR is there, there is no role of BDR, na?
I didn't get it. Can you repeat?
Until unless DR is active, there is no role of BDR.
BDR is backup. Just
BDR is backup. So it works like a simple kind of DR. Standby DR only.
Network route. And this is called summary.
Summary. Yes.
Fourth is summary ASBR.
ASBR.
Fifth is external.
And fifth is
external.
IP OSPF route. IP OSPF database external.
Yeah. Okay. We will write the command show IP OSPF database complete information.
It will complete information.
Show IP OSPF database
router network summary SB.
Show IP OSPF network type 2. Show IP OSPF
summary type 3.
Type 3 and data.
This
so
is
IP OSPF
data summary.
So let me type the command. Usually I don't type this command. So IP OSB SB database. Of ASB.
Yes, summary will not be placed. Summary is not okay.
And then show IP OSPF external.
Here also summary. Okay, external. Okay.
So these are the individual commands.
Great.
This is the brief of all. Right. So with this, you're done with OSPF.
OSPF. Great. Ishak, just one request, if it is possible for you, can
Okay.
you share that PPT, OSPF PPT?
I'll share now. Okay. I'll share too with this one. Okay, no problem.
That thing actually, that PPT that you are using yesterday, na?
Yeah, I'll share
With
it.
the name of OSPF, because that is very concise
Yeah,
content,
yeah.
na?
Yeah, I'll
Yeah.
share.
And our book Vandalodom is so descriptive,
Yeah,
like
yeah.
a lot of theory.
Yeah.
So
This is covered in 4 chapters. I think less than this. Some. Okay?
no, there are 3 chapters, I think,
Yeah.
Ishak. For OSPF, only 3 chapters there.
Mhm.
Yeah.
Okay. So this is our OSPF. So
OSPF.
tomorrow we can start switching,
Switching.
or we can go for access list and matting. After that also we can start switching. It's up to you. Okay. So you can decide whether you want.
Anything that you want. Yeah.
Yeah, let us see. Let us. Okay?
Mm.
Switching will be easy. So let us, because
Let us do switching, I think, because it will be a kind of breathtaking period while we will be studying, because SPF was very much, kind of
OSPF is very heavy. Yes.
heavy. So maybe, I mean, tomorrow we can start switching, huh?
Switching, yes, right. Okay.
Okay.
Any questions, anyone?
So please send it after some time, because I will actually, what we are actually trying to complete OSPF like by tomorrow, and then after, if any questions from our side, we'll ask you.
Yeah, no problem.
Yeah.
Right. So we will continue tomorrow. Okay.
Yeah. Thank you so much, Ishak. Bye bye.